So we entered uncharted waters here in the previous video because the setup assistant did not fill anything here. Well, at the time of making this video, there is active work in progress by MOVEit developers to fill this in as well for us. Nevertheless, this is a really crucial step when we want to take our first steps towards real-world applications. So let's find out where, what, and how to find the information that should go in here before we fill it in. So let's again look back at our manipulation overview. As we saw in the last video, the controllers file was a part of trajectory execution launch files. In essence, we are focusing on the part where we are ready to execute a motion. Now, where are trajectories executed? On a simulated robot or on a real hardware. What controls trajectory execution in simulation or real hardware? A controller on the simulator or a hardware driver that can move the robot joints by taking the provided waypoints and timing information as reference. In this course, we are using the Gazebo physics engine as a simulator for our robots, and in many ways, we can consider Gazebo to be a replacement for real-world hardware. Everything related to simulating our robots in this course is provided in the hrwros_gazebo package that comes with your installation. Good. Then, how does MOVEit talk to these Gazebo controllers? Via ROS topics and action servers that we learned about in week 1. And these are exactly what we have to configure in the empty file we saw. So let's now first understand the necessary details then. Please listen carefully, as this is crucial for many things we are going to do in the next videos and also our future life with ROS and MOVEit-based real-world applications. So we have our Gazebo simulation. This is developed by leveraging the Gazebo_ROS simulation package that comes with the ROS installation. For this course, we have grouped all that in the hrwros_gazebo package, and the simulation has been configured to provide a couple of controllers. First, a joint state controller that publishes the current joint values of our robot arms on the /joint_states topic. In this context, this controller is doing more of the job of a sensor publishing joint values than actually controlling anything. Second, a joint trajectory controller that provides an action server of type follow joint trajectory, which MOVEit will communicate with using action clients. Recall again, we studied action servers and action clients in week 1. Other types of controllers can also be configured for a Gazebo simulation, but they are not necessary in this course. Okay, now let's go on to the MOVEit side of things. All the MOVEit magic that we have spoken of in the earlier videos happens in the MOVEit packages that also comes with the course installation. Also, in the previous video, we created the hrwros MOVEit config package to enable our ROS application to use MOVEit. And MOVEit has a module called the planning scene monitor that uses the information in joint states topic to update the positions of things it knows about, such as our robot arms and other objects in the world. And MOVEit also has a simple controller manager module that allows us to configure a follow joint trajectory action client for the follow joint trajectory controller. So the plumbing between MOVEit and our Gazebo simulation is clear now. And the same also applies when we work with real robot hardware. In that case, we will have to use a robot driver instead of Gazebo though. Now that we understand this conceptually, let's fill up our empty file following the standard YAML and launch file syntax to configure our controllers. So here is our empty file again. To fill this in, we need some administrative information about the controllers from the hrwros_gazebo package that MOVEit can use, such as their names and types. Let's then go and see what's in the hrwros_gazebo package. It is convention that all controllers that we configure to be used with Gazebo are in the config folder. And as you can see, There is one joint state controller for each robot and one controller for trajectory execution on each robot. Let's first look at the joint state controller for robot 1, which is called R1 joint states controller and has the joint state controller type. And the same for robot 2, just with a different name. Now, the trajectory controller for robot 1. The trajectory controller is called robot1 underscore controller and it controls the 6 joints. Also, it is of type joint trajectory controller, which is a subcategory of the position underscore controllers in Gazebo. It also has some more additional settings in the constraints section, which has to do with trajectory execution tolerances, which we don't have to worry about in this basic course. And the same goes for the second robot, just has a different name, robot2 underscore controllers, and the corresponding robot joint names. Remember, we also learned that these controllers are provided as ROS action servers, which means some node will have to provide them. And how do we start multiple ROS nodes? Using launch files. So let's go to the launch folder and open the spawn underscore robots.launch file. We see here that the settings for the 2 controllers are loaded onto the parameter server and they are available in the /robot1 namespace. Similarly, the controllers for robot 2 are loaded here and are available in the /robot2 namespace. Very good. So let's still move it. Following similar logic as our Gazebo package, we go to the config folder in the hrwros underscore moveit underscore config package and create a new file called controllers.yaml like that. Then let's list our 2 controller clients. Each client has a name where we specify its name and in what namespace it is in. Then we have the action namespace. The follow joint trajectory action is available in the follow underscore joint underscore trajectory namespace in our ROS installations. And lastly, we specify the list of joint names, which we can take directly from the Gazebo controller. And so we do the same for our second robot. Now we have collected all information necessary to fill up our empty controller manager file. We first update what we are going to use as controller manager in the moveit underscore controller underscore manager parameter. Remember, this is the parameter used by moveit's trajectory execution handler when we are not using a fake controller. And we also learned that moveit provides a simple controller manager plugin, and we can specify that in our configuration file like this. And finally, we load the file where we defined our controller clients for moveit. Awesome. We are all set now to move our robot arms. Come back soon to see them move.